Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 147, determine the moment of inertia with respect to the u-axis without using the transformation equations and verify the results by the transformation equations. So let us accept the challenge that we will not use the transformation equations. So if you look at the figure, this consists of three triangles with respect to the u-axis. So for our solution, let's draw a line from here to this point of the intersection of the upper corner, this one, and this one also. Take note that this is 6 and this is 30, therefore this length from this point on the top of the rectangle to this corner here, that is sine of 30 is 6 over hypotenuse. So the hypotenuse is 6 over sine 30, so that is 12 inches. Then from here to this end here, as we will call that as B, then we have a right triangle, angle 30. The base is 12. So cosine of 30 degrees is 12 over B. So cosine of 30 degrees equals 12 over B. So therefore B is 24 over square root of 3 inches. So therefore this base of this triangle which lies outside the rectangle is B, which is 24 over square root of 3 minus 12. So we need the height. So this height here, perpendicular to this big triangle, this big triangle here, this is equal to 12 inches hypotenuse, this 12 here, then times sine of 30 degrees, so that's also 6 inches. Then for the height of this triangle, this height is, so this 6 inches is the height of the big triangle. Then this triangle here, biggest triangle in this figure. Then for this triangle, the next big triangle, this height is equal to 6 inches. This is 6 inches. And since this is 30 degrees, 60 degrees, so it is 6 sine of 60 or 6 cosine of 30. And since cosine of 30 is square root of 3 over 2, so this is 3 square root of 3 inches. Then, for the height of this small triangle which lies outside the rectangle, to be subtracted later, is equal to, remember this is 12 inches and this length is hypotenuse 12 for this right triangle. 12 cosine 30 is 6 square root of 3. So that is 6 square root of 3 inches. If that is 6 square root of 3 inches, then this is equal to the hypotenuse of this small right triangle here. This is equal to 12 inches minus 6 square root of 3. So since this is 30 degrees, this is 12 minus 6 square root of 3. So quantity 12 minus 6 square root of 3 times sine 30 is like quantity 12 minus 6 square root of 3, then multiply that by 0.5. So therefore, the height of this small triangle is 6 minus 3 square root of 3. How is this computed? Quantity 12, this length, quantity 12 minus 6 square root of 3, then times sine 30. So that's the opposite. So it's like hypotenuse sine of 30. So that's why it's 6 minus 3 square root of 3. So we can now compute I sub u. It is just moment of inertia of the three triangles about the base, which is base height cube over 12. But the bases are different for the three triangles. Then this one we have to subtract. So for the biggest triangle, the base is B, and B is 24 square root of 3. The height is 6, so 24 square root of 3 is 6 cube over 12 for the biggest triangle. So 24 square root of 3 times 6 cube over 12. For this next triangle here, with respect to the u-axis, which is the base is 12 inches, that one. Height is 3 square root of 3, so 12 times quantity 3 square root of 3 cube over 12. Then finally, we have to subtract the moment of inertia of this triangle with respect to the u-axis, which is the base. This base here is b, which is 24 square root of 3 minus 12, and that's the height. So it is quantity 24 minus 12 times quantity 6 minus 3 square root of 3 cube all over 12. Simplifying, the first term is equal to 249.415. The second term is 140.296. The last term is negative 0.08036. Combining, I sub u is equal to 389.63, supposedly 63 inches to the fourth to 5 significant figures. So take note that is 389.63. We round off value to 4 significant figures, so 389.6. Using the transformation equation, I sub u equals 1 half of I sub x plus I sub y plus 1 half of quantity ix minus iy times cosine of 2 theta, where 2 theta here is 60 degrees, 2 times 30 degrees, and that is counterclockwise from the x-axis, so positive. Then minus pxy, product of inertia x sub y, times sine of 2 theta. So that's the formula for RU. 1 half of I sub x plus I sub y plus 1 half of quantity ix minus iy, then minus p cosine 2 theta minus pxy sine of 2 theta. That's the transformation equation for moment of inertia. Now ix is equal to 12 6 cube over 3 because it is rectangle with respect to the base, which is the x-axis. So 12 6 cube over 3, and that is equal to 864 inches to the fourth. Iy on the other hand is 12 cube times 6 over 3. 12 cube times 6 over 3. So it is equal to 3,456 inches to the fourth. Then finally, product of inertia with respect to xy axis is by transfer formula with respect to the centroid 0 plus area, which is 12 times 6, barred x, which is 6 inches, barred y, which is 3 inches, half of 6. So pxy equals 0 with respect to the centroid, area 12 times 6, barred x 6, barred y 3, so 1296 inches to the fourth. We then substitute into the equation. Take note that 2 theta is 60 degrees. So I sub u equals 1 half of quantity 864 plus 3456 plus 1 half of quantity 864 minus 3456 times cosine of 60 degrees minus 1296 sine of 60 degrees. So 2 theta is 60 degrees, so minus 1296 sine of 60 degrees. So computing, I sub u is also the same as this. To 5 significant figures, 89.63 inches to the fourth. So that shows that our calculations here, which we challenge ourselves to compute without using the transformation equation, is the same as using the transformation equation. So that's it, and I hope that you are able to follow the solutions. Level 148, locate the centroid, barred x, and barred y of the cross-sectional area and then determine the orientation of the principal axis, which have their origin at the centroid C of the area. Also find the principal moments of inertia. So we will develop an expression later for the principal moments of inertia, the maximum moment of inertia, maximum and minimum moment of inertia. So we will divide for our solution the area into rectangle, vertical rectangle, and horizontal rectangle as shown. So that's the dividing line. The area of this rectangle is 6 times 0.5, so 3 square inches, while the area of the horizontal rectangle is 6 minus 0.5, so 5.5 times 0.5. So that would be 2.75. Therefore, the total area is 3 plus 2.75, 5.75. So 5.75 barred x is equal to 3 times 0.25 plus 2.75 times 3.25. So of course, 0.25 is half of 0.5 for the vertical rectangle. And for this horizontal rectangle, since its length is 5.5 divided by 2, 2.75 from this point here. So 2.75 plus zero point 0.5 from the left edge. So that's why we have 3.25. Barred x therefore is equal to 1.685 inches. Similarly, 5.75 barred y is equal to 3 times 3 plus 2.75 times 0.25. Barred y is also 1.685. So barred x equals barred y equals 1.685. For the product of inertia of area, for the rectangle with respect to the centroid 0 plus area 3 barred x 0.25 barred y 3 for the vertical rectangle. This is the formula for I sub u. 1 half of ix plus iy plus 1 half of quantity ix minus iy cosine of 2 theta, then minus product of inertia xy times sine of 2 theta. Now, if it is with respect to the centroid, all you have to do is put barred at the top of the symbol I, as well as for the product of inertia. So from the figure, the derivative of I sub u with respect to theta is equal to 0 because this is constant. 1 half quantity ix minus iy. Derivative of cosine is negative sine 2 theta. Then derivative of 2 theta with respect to theta is 2. That's why the derivative, so we copy this constant here, 1 half of quantity ix minus iy times negative 2 sine of 2 theta. Then minus pxy, the derivative of sine 2 theta is cosine 2 theta, then times derivative of 2 theta, which is 2 with respect to theta. So equals 0 because we're going to maximize the moment of inertia, maximize or minimize, so we still equate it to 0. So this means that we have the slope of the curve between I sub u and theta. Then simplifying, cancel 2, so we have ix minus iy times negative sine 2 theta, then transpose this to the right equals 2pxy cosine 2 theta, or pxy times 2 cosine 2 theta. Tangent sine 2 theta over cosine 2 theta is tangent to theta is equal to negative pxy, negative 2pxy over ix minus iy, which can be written as tangent to theta equals negative pxy only all over quantity ix minus iy all over 2. So tangent to theta equals negative pxy all over ix minus iy all over 2. So that's the expression for the location of the principal axis. We call that principal directions, principal axis. So there are two, and they are separated 90 degrees apart in the real picture, in the real situation. In later, it is times 2. So 180 degrees apart because we have tangent to theta here. So if we draw a triangle defining tangent to theta, the opposite side would be negative pxy. The adjacent side would be 1 half of ix minus iy quantity. Therefore, the hypotenuse is square root of quantity 1 half ix minus iy square plus pxy square, because negative of pxy quantity square is positive p square xy, or pxy quantity square. So substitute here because we already defined tangent to theta, and this is the triangle. We replace cosine 2 theta here by quantity ix minus iy over 2 over hypotenuse. So I sub max or minimum equals 1 half of quantity ix plus iy plus 1 half of quantity ix minus iy cosine 2 theta, and cosine 2 theta is 1/2 of quantity ix minus iy over the hypotenuse, which is quantity ix minus iy over 2 square plus p square xy. Then minus pxy, sine 2 theta is negative pxy over square root of quantity ix minus iy over 2 square plus pxy quantity square. So take note that the numerator is actually the same as the denominator that is free of radical. So uh, it's like quantity divided by square root of quantity. Therefore, if you simplify, that's the square root of same quantity. So that is, if we simplify these two terms here, that is the same as square root of quantity ix minus iy over 2 square plus p square xy. So therefore, I max or I minimum is 1/2 of quantity ix plus iy plus minus square root of quantity ix minus iy over 2 square plus p square xy. Similarly, the product of inertia PUV, which is 1/2 of quantity ix minus iy sine 2 theta, then plus pxy cosine 2 theta. That's the formula from transformation equation. 1/2 of ix minus iy sine 2 theta plus pxy cosine 2 theta equals 0. Why 0? Because if you substitute sine 2 theta, which is negative pxy over denominator divided by square root of quantity ix minus iy over 2 square plus p square y, then plus pxy cosine 2 theta, which is ix minus iy over 2 divided by square root of quantity ix minus iy over 2 square plus p square xy. So they are the same terms. So the first term is negative, the second term is positive, and they are like terms. That's why the result is 0. That means that the product of inertia with respect to the principal axis, remember, principal axis is where uh, we can find maximum and minimum moments of inertia of area, is actually the axis of symmetry. Remember that when the area has an axis, at least an axis of symmetry, the product of inertia is 0. So that means that the principal axis is an axis of symmetry. Then, the formula for tangent to theta for the principal directions is tangent to theta is negative pxy over quantity ix minus iy all over 2. So you have to remember this for this maximum and minimum moments of inertia of area. So let us continue the problem. So this is the figure. So we can now compute ix and iy, then product of inertia xy. Then let's just use the transfer formula to make it uh, simpler, not complicated if we directly compute for the product of inertia centroidal moment of inertia with respect to x and y, as well as the product of inertia centroidal product of inertia. So from the figure, ix is 0.5 times 6 cubed over 3 for this vertical rectangle. For the horizontal rectangle, the width or the length is 5.5, sorry, 5.5. The thickness is 0.5 cubed divided by 3 because it is with respect to the base. And take note that ix equals iy because of symmetry with respect to the edge, left edge, and with respect to the bottom edge. That's the same rectangles. So it is equal to 36.229 inches to the fourth, and that is also equal to iy. Because barred x is also equal to barred y, which is 1.685 inches from our preceding calculations. So for pxy, it is with respect to the centroidal axis 0, then area of the vertical rectangle, which is 3 square inches, then barred x is 0.25. I hope you can read that, and barred y is 3 inches, half of 6. Then for the horizontal rectangle with respect to the centroid 0, then plus area 2.75, barred x 3.25, barred y 0.25 as calculated and computed in the preceding slide. So plus 0 plus 2.75, 3.25 times 0.25. So product of inertia with respect to the xy axis is 4.4844 inches to the fourth. Let's now apply transfer formula to solve for I barred x and I barred y as well as P barred xy. Now I barred x equals I barred y equals Ix minus area barred y square for Ix. So that is 36.229. Ix equals I barred x plus area 5.75, then barred y square, which is 1.685. Anyway, barred x is also 1.685. So I barred x is equal to I barred y, and it is equal to 19.903 inches to the fourth. Then pxy equals p barred xy plus area barred x barred y. So 4.4844 equals p barred xy plus area 5.75. Barred x is 1.685. Barred y is also 1.685. So p barred xy is equal to negative 11.841 inches to the fourth. So having found this, let's now have our transformation equation for maximum moment of inertia. It is 1/2 of Ix plus Iy plus minus square root of quantity Ix minus Iy over 2 square plus product of inertia square with respect to the centroid. Tangent of 2 theta p is equal to negative 2pxy over Ix minus Iy over 2. Remember the formula we derived in the preceding slide. So everything has a value. So tangent to theta p, p means principal axis, or you just put it p or theta, negative 11.841 over 0. But since this is undefined, the tangent function is undefined in when 2 theta is 90 degrees, because tangent of 90 degrees is undefined, and negative 90 degrees. So 2 theta p is 90 degrees and negative 90 degrees. Therefore, the angle theta p, where we can get the principal or maximum moment of inertia and minimum moment of inertia, would be 45 degrees and negative 45 degrees. So that's the answer for the principal directions. Then for the maximum value and minimum value, I max, I barred max or minimum is 1/2 quantity I barred x plus I barred y, then plus minus square root of quantity I barred x plus R barred y over 2 square plus product of inertia xy barred square, p barred xy quantity square. So substitute 1/2 of quantity 19.903 plus 19.903 plus minus square root of 0, because the I barred x and I barred y are equal, then plus negative 11.841 quantity square. So this would be 19.903 plus minus 11.841. So for the maximum, I barred max is equal to 31.74 inches to the fourth. For the minimum, 19.903 minus 11.841 to 4 significant figures. That would be 8.062 inches to the fourth. So that's it for this problem. And we can get rid of the formulas, but you have to remember the formulas first. We can make the solution simpler by using the geometric approach, and that is recommended and developed by German engineer Otto Mohr. So we use Mohr circle in the following slides, maybe, to simplify the solution.